where we had left off last time. I'll rush through in the beginning because we had already discussed this, and today being a Friday class, we have little time left. I'll just rush through what we were discussing last time. We had begun on uh, expert system, and I said that it's basically a knowledge intensive program. And the easiest definition that we can give of expert system is it's any computer program that imitates human behavior or any human expertise. Now, it is used, basically, what it does is the way a human being thinks, reasons, analyzes a situation to come to a decision. The same the same pattern is converted into his thinking pattern is converted into a program and fed into what we call an expert system. So the way a person actually thinks uh, um, uh, to analyze a particular situation and come to a decision, that is programmed into a software. So we call it as we can define it as a computer program that imitates human behavior or emulates human behavior. Now it has a little management application, and its application in management science is limited, and but it has extensive um, usage in the medical science, geological survey, and the scientific fields. We took an example of dendril, which is used basically to identify the structure of a chemical compound, prospector to identify sites for drilling. So you can take soil of that area and can understand how much quantum of oil is there, how rich is the oil, is a oil base. Then the other very prominent is knife, K for knowledge, KN for knowledge, I for information, F for fusion, and E for exchange, which was used extensively by the US to make right military decisions, to identify how much soldiers you need to send in one direction, therefore how much food, ammunition, arms, ammunition would go in that particular direction. Another prominent example is that of mycin, which is a large expert used in the medical science for detective for detecting the disease of the brain, which we call meningitis. So it is used to give consultative advice on bacterial infection in blood and the disease which is a disease of the brain, which we call meningitis. So how a doctor here would think, his pattern of thinking was programmed in the form of a software. Basically, these are the developments in artificial intelligence which provides you information on how to analyze a problem. There were 3 stages of development which we discussed in the last class. One is natural language processing, robotics, and expert system. Natural language processing are computer programs which use common syntax like find, warehouse, where floor is equal to 3. So the syntax here is find. It is used which is used in what we call COBOL. That's for common business oriented language. Fortran is for formula translation. It is also used for as second stage of development is robotics, which sees changes in the environment and responds accordingly. So they are visual and tactile programs. Visual is a program of sight, and tactile is a program of touch. Robots do the DDD, that is the dull, dirty, and dangerous work, and the CBR, complex, boring, and routine work for human beings. One example we took is stacking of large units, say boxes and cartons, close to the ceiling in a warehouse, and the work that is done in a restaurant is done by a robo. So they open the door when you reach the restaurant, they pull a chair for you when you reach a table, and so on. Then the third is what we call expert system, which does the mental work. Robots do basically the manual work. Experts do the mental work by emulating or mimicking human expertise, and specific domain knowledge is used here, and it uses a reasoning strategy. Now, they are also categorized in terms of levels. The first level are the robots which handle the manual work for you. The second level is the stage of development of experts, which works on consultation. Like we took the example of a um, uh, specialist working in a primary health center in USA, where with a system they would be able to diagnose whether the person has meningitis or not, and that was done through consultation. You just went with your problem. I have a headache. That's it. Then the system will ask you which part of the head do you have headaches. You say, then they give you options like A, forehead; B, top of the head; 3, back of the head, and so on. So you tick on forehead. So the next query comes to you. It pops up a question like, is it there throughout the day? Slight migraine throughout the day. B option, severe headache at the end of the day, and so on. So you tick one option, slight migraine throughout the day. The third question that pops up is, uh, say, is it associated with some other feeling, nauseatic feeling, dizziness? A, nauseatic feeling; B, dizziness; C, and so on. So you tick on. So they're following, it is working on consultation. And this is what experts do. They cannot work independently, they work only on consultation. The third level is where the research is still going on, which is a true expert, where they will decide for you. There will be no consultation needed. And because expert system work on consultation, we also call them peers. Now, there are three components of expert system. One is a knowledge base, second is inference engine, and third is a user interface. Knowledge base is that component which holds the knowledge, which has tapped the knowledge of an individual. So it is one component of knowledge related to any specific domain of expertise. And here there are, the knowledge base further is divided into small components like facts, and for which there are no two opinion. So we talk of that case, mycin, when it interacts, they ask you questions like, which part of the head do you have headache? How often does this occur? Is it throughout the day? Or severe headache at the end of the day? So they are following, and they ask you, what is your age? So they try to combine whatever information they've extracted from you with certain fact. What is your age? So if you fall in the pediatric group, the diagnosis would be different. The drug that they would give you would be, the prescription would be different. So facts are those points for which there are no two opinion. So if you're 18 years old, fine, you're 18 years old, you're in the adult group. If you're 7 years old, you're in the pediatric group. So facts are statements that associate elements of the subject domain with truth values: age, sex, EPS, earning per share. So if you want to give a loan, or you want to do, so you will see the EPS of the company, right? So your salary, that's a fact. So if a company wants, if a bank, you go to take a loan from the bank will see your salary statement. How much money do you have? How much do you draw every month? So that's it. What is the, they will try to calculate your EMI, equated monthly installment. That is how much you can repay per month. That is based on how much salary you are drawing, how much money flows in, how much of work experience is how much of work life is left for you. So I have another 10 years for my retirement. So you can repay me in a maximum period of 10 years. So these act as facts. These act as facts. Your EPS is a fact, your age is a fact, your salary that you draw is a fact, how many years of service is left for you is a fact. On that basis, they will calculate your equated monthly installment. That is how much you would repay as a loan from repay to the bank every month. So that is EMI, which is based on certain facts. So these are certain facts. Second is procedural rules. Procedural rules are a sequence of actions in the subject domain. So when I asked a question, the query was, which part of the head? Next, how often do you have it? Third, it is associated with any other feeling like dizziness, nauseatic feeling. So there's a certain sequence in which the queries come about. So those are the procedural rules. And third is heuristics. Heuristics are basically thumb rules, which we call thumb rules in colloquial terms. It is my hunch. Because of my experience, I have certain heuristics, which also comes to play when I take a decision. So what are these heuristics? Heuristics are thumb rules. Like my belief is, since I've interacted or worked for last 20 years, maybe my experience that is that girls are more serious students. I might be wrong, but that is my experience. That is my thumb rules. That is my hunch. My hunch. So it could be just anything. It could be just anything. So these are also fed in your mind, and you're in your system, and you decide accordingly. So knowledge base is one component. It's a component of knowledge related to specific domain of expertise. It's a component of knowledge related to specific domain of expertise, and they can be broken down into three smaller components. So they are facts, procedural rules, and heuristics. Next component is your inference engine, which accesses the knowledge from the knowledge base, uses the knowledge stored therein, and uses a search strategy within itself. So there is a search strategy for coming to any decision. So you would not, so they use this kind of a search strategy and makes association and inferences within them. And third is the user interface. Because if user interface is needed in order to get the two components together, in order to get knowledge from the knowledge base, use the strategy, inference strategy, or the search strategy which is held within itself, and then come to a conclusion. So user interface, because it's an interactive software, it is not working on its own, it is interactive. So you need to access knowledge from the knowledge base. You need to use the search strategy within the inference engine, and then you come to a particular conclusion. So these are the three components. The three components are knowledge base, inference engine, and your third is a user interface. Within the user interface, we also have a what we call an explanation subsystem. So if you want, you can query and find out what was the reasoning strategy used to come to this particular decision. What was the reasoning strategy used to come to this decision? So there are three components: knowledge base, inference strategy, and user interface. So user interface is a software program which is needed to communicate with the user. It also has an explanation subsystem within itself which describes the reasoning strategy. Now, what are the features? Now we have discussed mycin, so you can just from there itself elicit the features. One is it works with incomplete information. So when you went to the doctor, you just said, I have headache. You didn't give the rest of the things. This is my age. It also is associated with dizziness, and it is on the forehead. You didn't give all the facts or all the information together. The rest of the information was taken out from you. So it works with incomplete information. Second feature, it works in consultation because query was made and you answered. And third, it uses a certain inference strategy, a sequence of steps before it comes to a decision. So these are the features: works with incomplete information, works on consultation, uses an inference strategy. So you think of mycin, you will come to know what were the basic features. Now the basic benefit is it captures expertise. Human expertise is captured and converted into a software program. A second benefit is it outperforms a single human expert. It can do better than a human expert. Third, it is faster and more consistent. It is faster. It can take a decision much early than you go on feeding. It depends upon how fast you feed the information. At that rate only, it will give you the answer. It will give you the diagnosis. So it is faster than human beings, and it is also more consistent. Why we say it is more consistent? Because human beings, if they are working, starting at say 9 in the morning, by maybe the evening he gets tired, but a software will not get tired. So it is faster and more consistent than human experts. First is the benefit is it can capture human expertise. Second, it outperforms human expertise. Third, it is faster and also more consistent than human expertise. Fourth advantage is it can capture the knowledge of several experts. It's not only one. So it captures the knowledge of several experts. It would not get tired, stressed, or distracted, which a human being is prone to. And you can preserve and reproduce that knowledge, isn't it? You can preserve it, and it can be replicated. But human expertise it cannot be replicated. So we often say, we often say a person leaves an organization, all the knowledge and the experience that he had also leaves with him. All the knowledge and the experience he had also leaves with him, right? But here you can preserve it because it's a program. You can preserve and reproduce this knowledge. So these are the basic benefits. These are the basic benefits. It captures human expertise. It outperforms human expertise. It is faster and more consistent. Then it can capture the knowledge of various experts. It would not get tired, stressed out, or distracted. And you can even preserve and reproduce this knowledge. So these were the benefits. Now, development of experts. There are 4 ways in which expert systems are developed. One is a rule-based knowledge. Second is a case-based reasoning. Third is forward chaining. And last is backward chaining. In a rule-based, knowledge is represented in the form of rules and statements, like a if-then condition. If this, then do that. So a if and then condition, like a decision tree. I think you understand what's a decision tree. And there's a series of questions and answers, right? So do you have a headache? It says yes. You came with a headache. It asks you a certain question. Which part of the head? Then it goes to a third question. So it has certain rules and facts. So if and then statements are conducted are like we say, if this is your salary, then if this is your salary, whatever is your salary, if this is the years of work life left, I have 10 years more to work, then this could be your EMI. They would calculate an EMI, tell you. So there are certain ifs, and then it goes to a certain conclusion. So it's like a decision tree. If the salary drawn is so much, if years of teaching life or years of working life left is this much, then this is your EMI. So there are certain if and then conditions. This is what we mean by rule based. Case based is a form in which it's a form of cases wherein you take the past experience. Okay, there was a problem. How did we analyze that problem, and what was the diagnosis? What was the solution? So you find similarity within the situation. Often we give this example of a Maruti Union problem. I don't know how many of you, it's a very prominent case of a management union problem, and how was it resolved? So when a problem arises in Hero Honda, they will try to reflect back. Okay, there was a similar problem there. How was it resolved? Okay, this was the solution given, right? So you find a similar case, refer back to the case. So this is what we call case-based reasoning. So what was the reasoning, or what was the strategy used in that particular case to devise a solution, and then you try to emulate that. You find similarity between the two situations, and you try to find a solution to it. This is what we mean by case-based reasoning. And the third method is what we call forward chaining. Fourth method is backward chaining. In a forward chaining, we start with facts and work towards the conclusion, like we did in the case of mycin. I have a headache. It is a migraine throughout the day. It is associated with nauseatic feeling. What I'm doing is I'm moving and collecting facts one by one. I am 18 years old, so I'm going on collecting facts, and then I come to a conclusion. This is how a forward chaining works. We go on compiling facts, and then we come to a decision. In a backward chaining, it's reverse. I assume I have meningitis, and then go on supplementing the information to see whether I was right. So backward chaining starts with a goal and works backward to put supporting facts. In forward chaining, we start with facts and move forward to arrive at a conclusion. In a backward chaining, the goal is there. So we start with the goal, okay, I have meningitis, and I work backward to support with facts. There's a similarity in case of this, like a budget. Like I said, every manufacturer, what does he do? He adds the cost of each component. Like I'm producing a car, I add the cost of the aluminum sheet which goes to make the body, add to it the cost of tires, add to it the cost of gear and engine, add to it the cost of inner plastic body, And then I moved to come to the final cost of the car. Final cost of the car was, say, 4 lakh something. I add a certain profit of margin and then I sell it. In a reverse situation, what do? Like it was in the case of a Nano, we started with the market cost. I will launch a 1 lakh car and then I work backward to derive the cost of tires, cost of gear and engine, cost of the aluminum body, and so on and so forth. So it's similar to that. In forward chaining, we go on acting, we go on collecting facts, and then we come to a goal, we come to a conclusion. In backward chaining, we start with a goal and try to support it with facts. So these are the 4 methods. The 4 methods are rule-based knowledge, which starts with a if-then situation; case-based reasoning, where we find a similar situation and try to arrive at a conclusion; and the last 2 are forward chaining and backward chaining. Now, who are the participants? Now, I'll just take 2 minutes and wind up. I know you have a class. The participants are a domain expert. You wind up a class at 9:20.
Okay, dear,
Yes,
I'll wind
ma'am.
up now.
Yes,
I'll
ma'am.
wind up now because I would like to spend some time on limitation on experts. Why is it has limited use in management science? So I wind up today. I think we have a class tomorrow. We'll carry on from here tomorrow. And sorry, there was some connectivity issues. I just could not connect. I was trying for quite some time.
It's
So
okay, ma'am. No problem, ma'am.
Not an issue. Thank you, ma'am.
Thank you, ma'am. Welcome,
Thank you,
dear.
ma'am.
Thank you, dear.
Thank
Thank you,
you,
ma'am.
ma'am.